Piaget's genius gave us the most comprehensive theory of cognitive development in psychology's history. But when researchers began testing his ideas more carefully, using familiar objects, simpler language, and infants rather than older children, they found that children develop many abilities months or even years earlier than Piaget claimed. His theory may have systematically underestimated children by making tasks more verbally demanding than necessary. Piaget concluded that infants lacked object permanence, the understanding that objects continue to exist when not perceived, until around 8 to 12 months, based on their failure to search for hidden objects. But René Ballargin's habituation studies revealed that infants as young as 3.5 months show surprise, measured by longer looking times, when a solid object appears to pass through another solid object, implying that they understand that both objects persist. The failure was in the reaching task, not in the conceptual understanding. Piaget's method conflated motor limitations with cognitive limitations. Piaget concluded that children in the preoperational stage lack conservation, the understanding that quantity remains constant despite perceptual transformation. But researchers found that when conservation tasks were presented using more natural language, familiar materials, and reduced verbal demands, younger children succeeded significantly more often. When a naughty teddy bear was responsible for the transformation rather than the experimenter, 5-year-olds who typically failed gave correct conservation answers, suggesting they understood the concept but were interpreting the experimenter's question as asking whether the transformation changed things. Piaget's theory depicted the child as a lone scientist constructing knowledge through direct interaction with the physical environment. Critics, particularly Vygotsky, argued that this systematically underestimated the role of social interaction, language, and cultural tools in cognitive development. Children learn enormous amounts from other people, through language, shared problem-solving, and instruction, not just from individual physical manipulation of objects. Cultural practices, symbol systems, and the accumulated knowledge of a society profoundly shape what children learn and when they learn it. Lev Vygotsky's zone of proximal development, or ZPD, is the conceptual space between what a child can accomplish independently and what the child can accomplish with skilled guidance and collaboration from a more capable partner. The ZPD identifies the frontier of the child's learning, where instruction is most productive because the task is challenging but achievable with support. Tasks below the ZPD are already mastered. Tasks above it are too demanding for any support to bridge. Effective instruction, by this model, operates within the ZPD rather than below or above it. Scaffolding is the dynamic, temporary support that a more capable partner provides to enable a learner to accomplish tasks within their zone of proximal development. Effective scaffolding is responsive to the learner's current performance. It provides exactly enough support to allow progress without doing the task for the learner, and it is gradually withdrawn as the learner's competence increases. A parent helping a child with a puzzle does not solve it for them. They guide, point, suggest, and offer encouragement calibrated to what the child can almost do. Scaffolding has been widely applied in educational design and tutoring. Vygotsky proposed that children's private speech, talking aloud to themselves while solving problems, is not mere egocentric babbling, as Piaget had suggested, but an important developmental tool. Children use private speech to guide their own behavior, plan actions, and regulate attention. This external speech gradually becomes internalized as inner speech, the verbal thought stream of older children and adults. Private speech is most prevalent during moderately challenging tasks, exactly where Vygotsky's theory predicts it should be most useful. Children who use more private speech during problem-solving show better task performance. Piaget and Vygotsky agree that children actively construct knowledge rather than passively receiving it, and both see the child as motivated to understand their environment. Their central differences are in the role of social processes and the universality of development. Piaget saw cognitive development as following a universal sequence of stages driven primarily by biological maturation and individual physical exploration. Vygotsky saw development as fundamentally cultural. What children learn, when they learn it, and how they think is deeply shaped by the specific cultural tools, language, and social practices of their community. Cultural variation in cognitive development supports Vygotsky. Dynamic systems theory, associated with Esther Thalen's research on motor development, offers an alternative to both Piaget's stage theory and Vygotsky's sociocultural account. The theory proposes that development is not organized into discrete stages, but emerges from the continuous, context-sensitive interaction of multiple systems: neural, motor, perceptual, and social, each developing at its own pace. A behavior that looks like a stage transition is actually the result of multiple developing systems reaching a threshold simultaneously. Thalen demonstrated that even basic motor milestones like stepping and reaching emerge from the interaction of body, brain, and environment. Piaget's contribution to developmental psychology is irreplaceable. He changed how we think about children's minds. But subsequent research has refined, corrected, and extended his theory in important ways, particularly by recognizing the role of method, language, social context, and culture. Vygotsky's perspective, long undervalued in Western psychology, has proven essential for understanding how learning occurs at the intersection of the individual and the social world.